Hello friends, today we are going to learn pharmacokinetic parameters. So in pharmacokinetic parameters, what are those important pharmacokinetic parameters? How to define that pharmacokinetic parameters and how to understand, basically more important, that pharmacokinetic parameters. So let us learn that. So before going into pharmacokinetics, how these parameters comes into the picture, that one should know clearly. So let us take an example of acute sickness like headache. Now if you suffer from headache, what you generally do? What all we generally do is we take a medicine. Say for example, a paracetamol tablet. If you take that paracetamol tablet, do you know what happens? First of all, it goes into solution form, and after in the solution form it gets absorbed in the blood. Okay, and then after 10 to 15 minutes, we start getting relief of that headache. Okay, so now question comes in mind, how it happens? What are the four basic processes which are responsible for this relief? So absorption, distribution, metabolism and elimination. These are the four basic processes of the pharmacokinetics: absorption, distribution, metabolism and elimination. And if you correlate the rate kinetics of this all four processes, CADME, it is called pharmacokinetics. I purposely wrote kinetics as a different part. It is an entire term, but kinetics is different because it carries a special weightage with respect to time. All these processes are time bound. Okay, so these are the four basic processes: absorption, distribution, metabolism and elimination, which governs the entire travel of your drug in the body. Okay, so now mathematically, if you want to understand, so consider another example. That is the first one. You take a medicine. Now another way to understand: after taking a medicine, at different time intervals, take a blood and try to measure the amount of that drug into different samples, time samples which are drawn at different time intervals. So you can have a plotting of one graph. You can plot the graph, that is called concentration versus time profile. Time may be in hours, concentration may be nanogram per ml or microgram per ml, whatever, it depends. So now at different time intervals you may have this kind of pattern. If you join that pattern, so there will be a curve, a graph, and that is called concentration versus time profile or graph. This graph is different for different molecules. This trend may be different for different molecules. So now, how to understand the various pharmacokinetic parameters? Okay, this is the first one. The maximum concentration achieved, that is called Cmax. The time at which this concentration is achieved, that is called Tmax. And the area under this curve, that is called AUC, area under curve. So in pharmacokinetics, Cmax, Tmax and AUC, these three terms carries a special weightage, because as I said, for headache the time should be very less to achieve this Cmax. Now you are getting me? Specific concentration must be achieved to get that pharmacological effect. That's why Cmax is important, Tmax is important, and the extent or the quantum of the what you can say is effect, what you expect, it depends upon the area under curve. So pharmacokinetically, if you want to learn, so Cmax, Tmax and AUC, these are the three terminologies which are very much important. Okay, so you got it, Cmax, Tmax and AUC, how to read it from the graph. And if you want to correlate these processes with the graph, it's very easy to understand. First portion of the graph will let you know about absorption. At this point, absorption is equal to distribution, metabolism, elimination. At this part, distribution and metabolism is dominating, and at the last portion, elimination is dominating. So got my point? So if you want to understand the pharmacokinetics clearly, one should have clear-cut understanding of graph, concentration versus time profile, and Cmax, Tmax and AUC. Thank you.